Salam and welcome everyone. So today we're going to be working on the question on the screen from one of my students who had this as one of their past questions for their upcoming exams. So this is not a question from the Physical Chemistry Atkins 11th edition textbook. This is a question from one of the past questions of one of my students. So the question says, 1 mole of an ideal gas is contained in a cylinder piston at 8.0 bar and 303 Kelvin. An isothermal and reversible expansion decreases the pressure of the gas to 6.0 bar. How much work is done by the gas during expansion? So the first thing you have to notice is this, that whenever you read a question like this, you have to look for like the keywords. So the keywords here is just the type of thermodynamic process that is going on, and we're told that this is an isothermal reversible expansion. So when something is isothermal, if you guys have been following my videos for a while, you're supposed to already know this. Isothermal means constant temperature. So this is a constant temperature question. And then reversible expansion, we're told that the volume actually increases. So V1 or V initial is greater, sorry, V initial is less than V final. So there's an increase in the volume. So, and this in turn decreases the pressure of the gas to 6.0 bar. So the next thing you have to do now is very, very simple. Since you know this is an isothermal reversible process, in this case an expansion, which is an increase in volume, which is basically what I'd explained earlier, you note that we have to use the formula relating to discovering the work done in an isothermal reversible expansion. So generally the formula is work done is equal to negative nRT ln V final divided by V initial, where N is the number of moles, R is the gas constant, T is the temperature, V final is the final volume, and V initial is the initial volume. But when you look at our question, we will see that we've been given the number of moles as 1 mole, right? It says 1 mole of an ideal gas. We've been given the initial pressure, okay, at 8.0 bar. We've been given the temperature, which is constant all through the whole process, as 303 Kelvin. Now, we've been told that there's an expansion, so an increase in volume, and this causes a decrease in the pressure. So now we have the P final to be 6.0 bar. And honestly, we are asked to find the work done. We see from the parameters that we're given that we have the value for a number of moles, we have the value for temperature, but we don't have the value for pressure or the value for sorry, well, we don't have the value for volume, and not just volume, but initial and final volume. We have none of the values for volume. Now you're going to be wondering, well, if this is the formula, how come you're giving us pressure and not volume? Well, you have to remember that regular chemistry that you've done when you were in Gen Chem class states that at constant temperature, so constant temperature, we have a situation where P initial, okay, V initial is equals to P final, V final. So if we want to keep this new equation right here in terms of V final, we end up with V final divided by V initial is equal to P initial divided by P final. So what this is telling you that when you have a constant temperature process, an isothermal process, you can rewrite the formula for work done to be work done is equal to negative nRT ln P initial divided by P final. With this, we have successfully determined the new formula, and we now know the value for P initial and P final. So the next thing you have to do is to simply substitute because you have all the values in this question. So you have work done is now going to equal negative N is just negative 1.0 mole times R. R is going to be 8.3145 joule per mole Kelvin. And the reason why you have to do that is because whenever you're asked the question, you have two different gas constants. You have the 0.08206 and you have the 8.3145. You have to look at the units of the final answer value, and the unit for work done is joules. So we have to put a gas constant that is related to joules. So hence why we're using the 8.3145 joule per mole Kelvin. So times 8.3145 joule per mole Kelvin times temperature 303 Kelvin times ln P initial, which is 8.0 bar, and then P final 6.0 bar. So you cancel out all of the units. So you cancel out mole, you cancel out mole, cancel out Kelvin, cancel out Kelvin, you cancel out bar, you cancel out bar. Now you may be wondering, why am I not putting pressure in a different units? Usually whenever you have joules, you're going to have pressure in pascals. Well, we're not changing it because honestly it's not going to make any sense, because we're dividing two different values for pressure within the ln, so it's not going to do anything mathematically, right? If you have like 4 over 8 and 1 over 2, if you take the ln of 4 over 8, okay, and if you take the ln of 1 over 2, you're going to get the same values, because it's literally the same thing. 2 divided 4 divided by 2, 8 divided by 2, you're just going to have, sorry, 4 divided by 4, 1, 4 8 divided by 4 2. So you're really handling the same thing. My point is, you're not going to switch the units because the units are already enclosed in the ln. So no matter what units that you're having, you're going to end up having the same value for the answer. So you're still going to have the fraction or the decimal of 8.0 divided by 6.0. So that's just what I'm trying to say. So anyways, work done is now going to be negative 1 times 8.3145 times 303 is the same thing as negative 2519.2935 joules times ln 8.0 divided by 6.0, which is just simply 1.3333. So that is basically this. So work done is now going to be negative 2519.2935 joules times ln 1.333. When you input that information in the calculator, you end up with negative 724.7493 joules. Now, I wanted to mention something to you, because an expansion is going on. I'm just going to teach you a little bit about the chemistry of it. Because an expansion is going on, the system is doing work on the environment. Hence, the system has less energy in form of work, so it's going to have a negative value. That is basically what's happening here. So work is being done, and that confirms our answer is correct, because we have a negative work done, because work is being done by the piston or by the system on the environment. So yeah, basically this is our answer. But we know that as chemists, we don't just keep raw values, we have to put it in the nearest significant figures that we're given in the question. So if you go to the question, we have 8.0 bar, 2 sig figs, and this 3 sig figs, and then 6.0 sig figs. Well, 2 sig figs is the lowest significant figure, so we have to put this answer in 2 sig figs. So that would mean work done is now going to be approximately negative 7.2 times 10 raised to the power of 2 joules. So this is basically the answer to this question. If you have any questions, please put it in the comment section of my channel. If you have any suggestions or concerns, also do that as well. As you can see, this is a question from one of my students, and when we worked on the past question for the upcoming exam that we're going to have. So if you have questions like this, make sure you email me, or if and if you would need help in anything physical, chemistry, and STEM related, just know that I'm the tutor for you. So if you're a student in whether you're in middle school, high school, college, I am the tutor who helps students that are studying STEM succeed in all of their STEM related courses. So if you would like to book a session with me, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Do not forget to ask me any questions you have in the comment section. Assalamu alaikum wa rahmatullahi wa barakatuh.